All right, here we are. Better late than never. Yeah, got these, we rely on these machines so much. And when they fail, it's just like, oh, oh. So, but it looks like we're back up and running. So I'm going to tweet out to the world that I'm live now. And I'm going to do the same thing on Facebook. Hey, everybody. Thanks for coming in. It is 2:18 UTC. So Astronomy Daily Live is starting a little bit late, unusually late. So, but that's what happens. I think it's this power outlet down here. I don't exactly know what causes it, what does everything, but everything that is connected to this power outlet, I've got. Well, no, it's not even that. I don't know. I don't. I yeah. There are some strange electrical things in this house that I've yet to figure out. It just baffles me. So, but one of them is that from time to time, pretty sporadically, pretty randomly, power will go out on this power strip down here below me and on my Linux machine. Um, my Linux machine is connected to a different um, um, power thing on the wall, and it just goes, just off and on, just blink, you know, just enough to wreak havoc. And this time, the laptop that is running this, I've got something in my eye, um, didn't like the fact that it was shut down right in the middle of. I think I was still. It was still booting up. So yeah, that's not a good time for a machine to have the power pulled on it. So yeah, I don't know what's going on there. It's all I can do is just ride the wave and cross some fingers and hope it doesn't happen again or doesn't happen very often because it just sort of sucks. So we lose a lot of time that way and um, yeah, it's always distressing when these machines go down. So yeah, glad everybody is here. Could join me in this sort of late edition, but you can check out the chat. Chat is probably up and running. I think I popped the chat out. Yeah, there's Space TV with his cool shades. And yeah, it probably is. It probably is the cat. We'll just blame the cat. Yeah, that's pretty funny. So if you've stumbled onto this channel somehow, I want to welcome you to this live stream. It's called um, Astronomy Daily Live, and you can call me Cosmic. And yeah, we just sit around, we gather um, a circle of friends, and we talk about this passion we have for the science of astronomy, and what a broad and awesome thing it is, and I think it's fantastic. I've been completely blown away by it for as um, as long as I can remember, and yeah, very early age, remember finding books in the library, um, and completely engulfing those, swallowing up whole, and then finding finding the main library downtown where it had a whole a whole shelf of just astronomy books and math books and physics books, and just it just awesome, right? And then finding the local university's library as a teenager, and finding a whole section just devoted um, um, to astronomy. And also, I think at that point, that's when I found all the journals, um, the Astrophysical Journal, the Astronomical Journal, Physics Today. There were a couple others, and just ate those up. Didn't understand a word. Didn't understand a word, but it didn't matter. It because this was astronomy, right? I mean, I was really diving into it. I didn't know anybody else uh, um, doing astronomy like that. But one of the first things I did was I found a local club, and you know members of astronomy clubs uh, love to talk astronomy too, and they really like new people. It's sort of like fresh meat, right? And they um, took me in. I was just a little kid, 12, 13 or so, and took me in, and um, we went on trips, to dark sites, did lots of observing, uh, had had lots of exposure, to different kinds of telescopes. Had a lot of fun, a lot of fun, and there were people in this club that spanned the spectrum, right? There were some really serious diehard observers who were like, we're not screwing around here, okay? We are observing, right? We're getting all the Messier objects. We're getting the Herschel objects. We are serious. We're not messing around. We're not joking around. We're going to go out and observe, and that was really awesome. And then the other side was all the people who were just there, to have fun, and the trips were fun, and lots and lots of jokes, and just great fun, and it was a great crowd. So if you're new to astronomy, the number one thing that I would say is to find a local club, because there you'll be able to um, go out on star parties and look through a bunch of different scopes, and those people will talk your ears off, right? They are nonstop. You can ask them anything, right? And I mean, that's why they're there, because they want to talk about astronomy. They want to talk about their gear. They want to talk about what they're looking at, what they're doing, the whole thing. Um, Now, there are going to be those who are, like extremely serious. And it's like, don't turn on that light. Don't turn on that light. Don't talk to me. I'm busy. I'm working, blah, 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 blah. And that's cool. Hit them up later, because they are a great resource as well. But for the most part, um, most of the members of the club are just there to have fun, because they share the passion, just like us here, and yeah. So welcome. Glad you could stop in. Sorry it's running a little bit late, but that's how it goes. Oh well. Cheers. See, I've got my coffee right here. That fixed everything. And yeah, it it's got to either be the tribbles, or the cats, or the uh, yeah, some kind of little gnomes or something, poking around in my power outlets. Maybe it's mice. I don't know. Who knows? But Yeah, no worries about that kind of thing. If yeah, I figured it would come back just fine. So I was watching Tony Darnell's latest video this afternoon. His what does he call it? The Space Fan News, and he was um, giving an update on things going on behind the scenes and everything else. He's always trying to make improvements. Excuse me. Holy moly. Um, as are we all, and he said something very very interesting. They I guess they were doing like a monthly show about Mars, and I think I, I don't think he meant it like this, but what he said, and I'm paraphrasing a little bit, but uh, he said there, you know, we're going to stop, you know, um, having a show just on Mars because there's nothing going on up there. Never joined an astronomy group where I live. Yeah, 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 yeah. Space TV, because of you, I have discovered SLU, and I love that name. It's such a cool name, and I've watched a couple of their shows, and they're very very awesome. It's I think what they're doing is absolutely fantastic, and it's extremely exciting. I really, really like the business model. I, I think that, I think that. Well, I hope it is working for them because operating that many scopes, maintaining, you know, uh, they probably have to have people there just in case, maybe not exactly on site, but they have to have somebody nearby, just in case, there's some kind of a problem or something, starts to rain and the dome doesn't um, close, you know, that kind of thing. But yeah, I am so impressed and I am so blown away by the quality of the production. The people uh, are really really smart, really really know their stuff, and uh, um, the images that they're getting from these scopes are absolutely fantastic, and it looks like they have sort of the full um, suite of support. So all the software to um, um, process the images and do all the stacking and all of that. I mean, some serious work has gone into this place. I think uh, they've been running for um, uh, several years, like at least 10 years or so now. So yeah, they probably have this down really really well. But yeah, uh, uh, I think it's fantastic, and I definitely look forward, to their uh, um, shows, that are coming up. The other one, I don't know if this is on Space TV or not, but the one that I found a little while ago is called uh, is called the Space Show. The Space Show. Now it's not about astronomy, right? It's mainly about space flight, uh, that kind of stuff. Talking about um, policy and plans and spacecraft, and Anyway, that's an awesome show too. I don't know if you've got that listed on Space TV or not. I don't remember how I found that, but I just recently found that one too. So yeah, definitely check out Slew. You can subscribe, and I think for like as little as like $5 a month, uh, you can you know take pictures through a I think they have I think the largest scope they have is like 20 inches or so. So half a meter, that's not bad. That's not bad at all. And you can snap a couple of pictures every month, and it's cool. It's very cool. You can also get a subscription for like 25 bucks a month, where you have unlimited, I think, um, chances at that. Hold on one sec. Kitty emergency. All right. Yeah. So for I think 25 a month, you can have um, unlimited um, access. At least that's how I sort of read that. Although, yeah, there's some kind of limitations, but not much. So for 25 bucks a month, um, you can have access to 6 telescopes, um, a solar telescope. It's really cool. Um, if you just want to take pictures. Now, I mean, I'm more interested in science, and so I'd sort of be interested in um, in knowing if these scopes can also be used for scientific work, photometry, that kind of stuff. Not quite sure if they are or not, but I I think it's fantastic. So check those guys out for for sure, for sure. Yeah, I think that is Doctor Space. Yeah, Doctor Space. Um, what's his name? Livingston. Is that it? Uh, type that in again. The space show. Space show. I think I posted the link to it over in Discord. Yeah, Dr. David M. Livingston. And yeah, they do a show, what, like 5 days a week or so. So that's pretty good. A couple hours every day. That's insane. It's some kind of call-in show. Well, I think they have an open thing where you can call in, but they also have guests, right? But that's talking more about space in in the sense that talking about space travel, spacecraft, missions, to planets, that kind of stuff, which I will certainly talk about here as well because that has to do with astronomy. Faux show. Anyway, so Tony Darnell, and as I said, I don't think he meant it this way, but uh, he said something like, "There's nothing going on at Mars," and so that sort of inspired me to, and I'm gonna share my screen here. I guess I have to do that first before I start moving around on the internets. Okay, so sharing the screen, going to infinity, hide that, go over here. I'm gonna go to my server, Discord server. Folks, it is getting warm here in southeastern Arizona. I guess the other day Tucson broke 90 degrees Fahrenheit, and it's definitely in the where I'm located. I'm usually about maybe 10 degrees cooler than Tucson. So we're definitely getting probably into the 80s Fahrenheit here. So that's not too bad. Dun, 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 dun. Let's see, we'll go over here. And then we'll go up here. I'm pretty sure I posted a. Yeah, unfortunately, some sometimes, Uncle Bill, I have to force crash my Linux machine, and I do it reluctantly, and yeah, not too happy about that. Let's see, there it is. So this is just a Wikipedia page listing all the missions to Mars, and so lots of failures, lots of failures. The Russians first tried, uh, some flybys back in the early 60s. Tried a lander in 62, never left low Earth orbit. So the first successful mission to Mars was Mariner 4, and that was a flyby. Uh, it's just a process, right? You do a flyby to sort of, recon, right? Reconnaissance, just to sort of see what's there, to get some close up, uh, um, some close up shots, and try to look for interesting places to maybe land, right? To maybe land, and as you can see, they did. The United States did three flybys in the mid to late 60s or so. Mariner 4, Mariner 6, Mariner 7. I don't know what happened to Mariner 5. What happened to Mariner 5? Does anybody know what happened to Mariner 5? It's not even listed. Interesting. Those kinds of things make me wonder. Uh, Mariner 7. Okay. Mariner 8 was a first orbit attempt from the United States. It looks like the Soviet Union tried some orbiters as well and failed to orbit. So they got there. That's pretty awesome. But Mariner 8. Hey, Samantha Connor. Nice to see you live. Hope everything's well. We're looking at the various missions to Mars that have occurred, well, since the beginning. Tony Darnell said this afternoon in his video that nothing's going on at Mars, and at least nothing worth talking about. And I don't think he meant it that way, but I'm sort of taking issue with that because it's I don't think that's very true. Um, but you have to prioritize things. So mostly successful. Mars 2, Soviet Union orbiter, mostly successful. Entered orbit on the 27th of November 71, operated for 362 orbits. Mapping operations unsuccessful due to dust storms. Oh, bummer. So yeah, they didn't see any. Well, I guess they didn't see anything or didn't see much, and oh, that really sucks. That's a lot of effort. That's a lot of effort, and they're going around, but you've got this like, I guess, planet wide uh, dust storm, which happens, you know, that does happen. And it's like, oh man, that sucks. That sucks. So Soviet Union tried a also a lander with Mars 2, um, but it failed to land. Failed to land. Don't know if that means that it crashed or if it never, if it, yeah, you know, there's not enough information here at all. Mars 3. Where'd I go? Mars 3 uh, entered orbit just a few days later, right? Entered orbit 27 November, entered orbit 2nd of December. Again, it had to deal with, you know, the dust storms. Um, Also sent out a lander. So it deployed from Mars 3. So the lander left left the orbiter, landed, landed, but then contact was lost 14 and a half seconds after it started to transmit. So, all right, well, you know, they landed it. They successfully landed it, and it sent a message home. You know, sort of oh well, oh well. Mariner 5. Okay, Mariner 5 was actually built as a backup. Um, uh, oh, cool. Okay, okay. Thank you, Space TV and Wikipedia. Uh, so they since Mariner 4, right? Since Mariner 4 did its thing up here, you know, successful flyby. Um, they were like, oh, okay, we've got this. Let's send Mariner 5 to Venus instead. So that's very cool. That's very cool. Let's see. So partial failure of the lander, although they made it. Um, they also, I guess, tried a rover as well. Same. I guess that's on the same Mars 3 mission. I guess I reading that right? Um, but that failed to deploy because the lander died. So yeah, that makes sense. Mariner 9 orbited 14th of November 1971. I was uh, I was 2 years old then. No, I was 3 years old then. 3 years old when Mariner 9 successfully entered orbit. Lasted 516 days, not bad. Mars 4, failed spacecraft. Mars 5, partial failure. Okay. Mars 6, contact lost upon landing. Mars 7, separated from coast stage prematurely. Oh, man. Then we have Viking, NASA, United States. Those obviously were extremely successful. So pretty good. You know, we went from, and you know, this is sort of the common thing, right? We do flyby, a couple of flybys, and we do an orbiter, and then we have a lander. Yeah, yeah. We're gonna get to the latest ones here momentarily, the operational ones. I just I'm I just like, you know, going through all of these because it's like, you know, it's been it's been a busy place. Now the interesting thing, and you know, this has been pointed out to me before, but it's very obvious now. look at this. From 1975 to 1988, nothing, nothing at all. And uh, I guess, I mean, I'm speculating here, but I guess there are sort of two reasons that come to mind right off the top of my head. The first is of course the United States and the Soviets were in a race to see who could land on Mars first. And when the United States won that little race, it's like, well, I guess there's no more reason to go to Mars, right? I think the other reason is, and actually, what's his name? Peter. Oh, he's the PI for High Rise now. Oh, I forget his name. I went to one of his talks at the University of Arizona, and uh, he said, that had, and don't quote me exactly on these numbers, but he said something like, if Viking had dug down another 6 inches or so, they would have found water ice. But because they didn't find any water on Mars, water ice on Mars, it was kind of like, okay, what do we do now, right? What do we do now? So so there's this huge gap, 13-year gap, uh, where just nothing happened, and I think it was a combination of at least those two factors. Was that the United States landed Viking, dug around, you know, did the landing thing, found found some really cool stuff, obviously, but didn't really find what they were hoping to find. So they were just sort of like, all right, well, let's just hang around here, see what happens. Yeah. So 1988 comes along and they decide that they want to orbit and land on Mars's moon Phobos. And that was a that was a failure. That was a failure. It's hard, They keep saying, and it's absolutely true, space is hard. That's a hard nut to crack. So, yeah, communications lost, failed to enter orbit. Um, so Phobos 2, the they they were able to orbit, but lost communication before the lander got down. Mars Observer 1992 lost communication before insertion of orbit. Yeah. Mars Global Surveyor. Yeah. Operated for 7 years. So there's 7 years worth of data there. This data is available, as far as I know, on I I'm pretty sure it's called the Planetary Data System, PDS. So you can find actually all the Viking data. I think all, like, Voyager and all of that. We're not talking about Voyager here, but I think all that data is available. So Mars Global Surveyor, 7 years worth of orbital data about Mars, as far as I know, is freely available. So there's a lot going on there. Um, uh, Russians continue to have problems with Mars, but Mars Pathfinder in 1996 successfully lands on the 4th of July, 1997. I remember that. That was an exciting day. watching that. You know, Pathfinder. Did Pathfinder? I don't remember if Pathfinder had a powered landing, or if they bounced. I don't think that they were. I don't think that they were the bouncing one yet. I think that was a powered lander, and the first rover on Mars, right? Sojourner, um, successfully deployed and operated. It says here for 84 days. So 84 days. I wonder if that is 84 sols or 84 Earth days. I don't know. So Japan got into it in 1988, failed, ran out of fuel. Oh, that majorly sucks. I wonder if they ran out of fuel because of complications, uh, you know, getting out of Earth orbit, or if they just didn't calculate the amount of fuel needed. Uh, yeah, yeah, it's probably Sol's, but you know, I I wonder about those kinds of things. You know, this is Wikipedia, so you know it's the information may not be as precise as we might want it. So yeah, I would like to see that expanded upon, mainly because if you look down like to spirit and opportunity, like spirit, it says Saul's. So just saying, ran out of fuel. Yeah, Mars climate um, orbiter. That one was a big oops, big oops. Unit conversion errors. Polar lander uh, failed to land. Deep Space Two, a penetrator. Okay, I don't remember that one, but it failed anyway because it apparently was part of Mars polar lander. I guess you know the idea there was is that you know they were going to send a thing you know like a spike down you know to get into the ice at the poles a little bit. So Mars Odyssey has been operational there. Um, it launched in 2001. It probably got there what in either late 2001, early 2002, and it's still going. Mars Odyssey. So let's just look at the instrumentation on Mars Odyssey. Scientific instruments. Let's see. What have they got on here? They have a thermal emission imaging system, a gamma ray spectrometer, and a Mars radiation environment experiment. And the gamma ray spectrometer includes a neutron detector. Okay, it's a thermal emission imaging system. Is this an actual, is a camera on board? It images Mars and in the visible and the infrared parts of the electromagnetic spectrum in order to determine the thermal properties of the surface and to refine the distribution of minerals. So this is still going on, right? This is still going on. And my guess is that all this data is available on you know, the planetary data system. Now, why would they show a picture of California? I don't know. Let's not look at California. I'm not interested in California. Bemis discovers variety of rocks. Map showing distribution of hematite in Sinus Meridani. This data was used to target the landing of the Opportunity rover. Okay, so yeah, you know they found an interesting outcropping of some rocks and say, hey, let's go land there. So that's very cool. So that's Themis. I don't know why it's doing that. Gamma ray spectrometer. Let's just take a quick look at this. See if there's anything interesting. Uses 32 watts of power. Along with its cooler, it measures blah, 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 blah. So not a lot of info on Wikipedia, obviously. We'd have to do a deeper dive into the paper here to actually see. And I'm not going to do that tonight. Mars Radiation Environment Experiment, MARIE, designed to measure the radiation environment of Mars using an energetic particle spectrometer as part of the science mission of 2001 Mars Odyssey. Okay, so this is just measuring microrads, millirads, microrads per day, and yeah, I'll bet you this data is available too. Don't know if it's still running or not. I assume that it is. But yeah, measuring the radiation environment around Mars. That's pretty interesting. That's pretty useful info. If we ever want to send people there, we have to understand how much we're going to have to protect ourselves. Now, my thing is, let's go underground. Okay, take Elon Musk's uh, boring company and his um, BFR, and send a couple of these boring machines up there to dig down underground and set your thing up underground. Then radiation isn't necessarily a problem, right? Let's see Mars Express. We can so there's enough fuel to remain operational until 2026. And again, I'm just going to look at the instrumentation on here. Scientific instruments. Let's see what they've got. Wow, look at all that stuff on there. Spectrometers, altimeters, measuring the plasma environment. Ooh, there's a camera. There's a high resolution stereo camera. Uh, Mars Express lander. I didn't know that there was a lander. And a Mars radio science experiment uses radio signals to investigate the atmosphere, surface, subsurface gravity, and solar corona density during solar conjunctions. Cool. So that is a packed machine. Oh, this was the Beagle 2. Yeah? I thought the Beagle 2 failed. Physical. Yeah. However, the landing attempt was unsuccessful. Yeah. So Mars, I'm sorry. This is, come on. Mars Express had Beagle 2 on it. Mars Express is still operational, but the lander, Beagle 2, failed to fully deploy after it landed. Yeah, I remember that. Yeah, Beagle 2. So Spirit landed um, on MER, oh yeah. So Spirit and Opportunity were two different spacecraft, but ultimately they were landers and rovers. Spirit went on, for 2,208 sols, and I think it got stuck. I think it got stuck in a sand dune or something. Is that right? I think a low power probe could make use of the temperature gradient between the surface and subterranean levels of, say, Mars crust to generate power for experiments. I don't know. I don't know enough about the um, the temperature profile uh, to really know. I think Mars is close enough to the sun that power really isn't a problem. Um, and once we sort of get, I think our um, uh, uh, act together and learn how to make fuel from the resources that are there, then it's even power isn't going to be a problem at all. But if there's enough of a temperature gradient, then it would just be like geothermal here on Earth, right? That's how that works as well, right? So yeah, I think that's a viable idea for sure, Samantha. Opportunity is still going, right? It just passed its 5,000th sol a month or so ago. Uh, so Rosetta flew by Mars, and then there's MRO. MRO is awesome, still operational, bringing back lots and lots and lots of data. I've gone through some of the high rise images on this live stream, and I will again. And it again is absolutely packed to the hilt with some major instruments, and then they're calling these engineering instruments. So in addition to the yeah, just packed, right? This thing is I don't know, is it bus sized? It's big, right? It's a big spacecraft. It's got a lot of room to put a lot of awesome instrumentation on board. And numlock. Where's my numlock? There it is. Um, and again, I think most or all of this data is available on the Planetary Data System PDS site. So MRO is very awesome, and it's been running since March 10th of 2006. So it's been going for 12 years now. Um, the Phoenix lander was short and sweet, but successful. They actually found water ice there. It's about time. Dawn had a gravity assist. See, the Russians again tried another tried another one and failed. Oh man. China got into the game in 2011, failed. Um, yeah, I guess. Okay, so it was sort of a dual thing with the Russians. That's cool. So Curiosity, of course, is still up there and running. Curiosity just yesterday or the day before passed its 2,000th sol. So congratulations to all of them for having 2,000 Martian days up there. That is just awesome, and it's still going. And we can see that data coming down on pretty much a daily basis. And I will definitely be looking at that again during live streams here because it is just so cool. to actually see little grains of dust on Mars. I think it's just absolutely fabulous. Now the Indians, okay, tried once and were successful. So, what do the Indians know that the Russians don't? I don't know. I don't know. But Mom has been up there for 3.5 years now, and I don't remember what kind of instrumentation they've got on there. I don't think they have an imager, but I could be totally wrong. Let's see. Payload, payload, primary objectives, scientific objectives. Okay, so it's got a Lyman alpha photometer. So it's looking at, you know, hydrogen, deuterium. It's got a methane sensor, uh, neutral composition analyzer. It's almost like a mass spectrometer of some sort. That's kind of cool. Thermal infrared imaging spectrometer, and a color camera. This tricolor camera gives images and information about the surface features and composition of the Martian surface. Cool. So they have a color camera going around Mars. That is very cool. That is so cool. All right, awesome. So that's Mom. We've got Maven. Okay, Maven, orbit insertion on the 22nd of September 2014. I don't remember what instrumentation is on Maven. We have scientific instruments. Here we go. So solar wind electron analyzer, solar wind ion analyzer, thermal ion composition. So yeah, just a lot of particle detectors up there, trying to understand, the electrical environment of Mars. As I said, that's an important consideration if you're wanting to put not only people up there, but have um, um, instrumentation up there that you want to last for more than a couple of minutes. So yeah, remote sensing package. It's a spectrometer. Um, so yeah, no imagers, but images. There's not there's there's a limited amount of information that you can get from an image. Okay, but if you have a spectrometer or a magnetometer, um, you get a lot more bang for your buck. Now you're not getting any of the pretty pictures or anything else like that. But if you want a lot of bang for your buck, you put a spectrometer on there and a magnetometer and these particle um, detectors, which you can't see with any kind of a camera. So cameras are nice. They serve a purpose, but if you have some kind of a limited budget, which I'm sure Maven did and does, then you've got to pack in as much as you possibly can. And if that means no picture taking, oh well, there's still a hell of a lot of science. There's still a hell of a lot of data. You just have to interpret it in a different way, and sometimes it's not incredibly obvious. Now, this one I don't remember anything about. Um, ExoMars. Yeah, okay, that rings a bell. And look, finally, Russia got on board with a successful operational orbiter. Phew! It's been in orbit what, about a year and a half or so. ExoMars. Let's see what's on that one, and then I'm going to let you guys go. Even though we started a little bit late, I still want to keep to the program. Let's see, payload. Okay, so yeah, see, that's another thing that these Mars orbiters are doing is they are acting as data relay stations. So all all the rovers and whatnot on the surface don't have to beam their data back to Earth, right? Which means they don't have to have all that instrumentation, all that extra power, blah, 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 right? They just have to be able to send this data to an orbiting spacecraft. And then the orbiting spacecraft can send all that data back to Earth because that's what they are set up for. So it's a relay thing. It's awesome. It's absolutely awesome. Uh, but obviously, that's part of what ExoMars is doing. Let's see. So it's got the nadir and occultation for Mars discovery. So spectrometers again, more spectrometers. Okay, so this has a imaging system, 4 meters per pixel. Wow, wow. I'm gonna have to see if we can find some pictures from Cassis. Uh, yeah, I'd be interested in seeing those. Um, and then there's a neutron detector called Friend. Yeah, very, very cool. The ExoMars lander crashed. Well, let's see. Does it say anything about that? I'm sure it does. Yeah, Schiaparelli. Yeah, yeah. I remember that too. So they're calling it a partial failure, though. See, the lander crash, but test declared successful. Critical data was retrieved. So yeah, well, it's hard. It's hard to do that. So yeah, I would say that except for this gap in time between 1975 and 1988, we've had a pretty good run with Mars, and what we've got four either four uh, well, where's yeah, okay, so four, five, six. I'm sorry. So there's 4, 5, 6, 7, 8. So we have 8 either orbiters or landers or rovers on Mars right now. So I would say I would contend that that we're doing quite a bit on Mars right now, and I would also think that there would be a lot to talk about. Um, so yeah, I think that's very, very cool. Mars is an amazing, awesome place that uh, we're just beginning, to get to know. I think I think the surface area of Mars is pretty much almost exactly the same amount as land area on Earth. I think that's true. So, oh yeah, there's a lot to cover. There's a lot to cover, and we haven't even made the tiniest of dents there. So yeah, I'm looking forward, to having people go there. I think we should definitely send, more rovers. You know, do more experiments, but set up operations there. Set up a base. Uh, you know, get this thing going. It's a cool place. It's a very cool place. All right, I am going to stop sharing. I'm going to get back on here, and I think I'm going to. Yeah, yeah. The mothership is calling. So I'm going to get out of here for now. I'm glad that um, whatever the laptop here had to do, it did it. The gremlins have exited. You know, maybe it was the tribbles. Maybe the gremlins ate the tribbles. I don't know. I don't know. But you know, hopefully, you know, the technical problems don't happen too often. I am, you know, dealing with sort of low tech here. But yeah, I think all is well. So if you haven't yet, make sure to subscribe to this channel. You can get notifications of when this is happening every single day. I am here usually every single day starting at 2 hours UTC. So you're going to have to figure out what time that is for your location. Um, Me being in southeastern Arizona in the United States, I'm 7 hours behind UTC. So for me, 2 hours UTC on the 24th of March is actually 7 p.m. on the 23rd of March. So yeah, you'll just have to figure out when that is. It's a good exercise. You know, understanding time is sort of your first step into the science of astronomy. You have to have a pretty good grasp of time, or at least how to measure time, um, if you want to get into astronomy at all. So, you know, being able to figure out what time this live stream starts for your location is sort of uh, your first test. So, and if you can work that out, then you are well on your way for sure. But so hit the thumbs up, hit the thumbs down, whatever you want. I'm interested in a reaction because I'm interested in the absolute value of of reactions, not actually what they are. So leave some comments down below. If you want to be on the panel here, throw me an email, cosmiclettuce@gmail.com, and when I go live, I can send you the link, and you can be a panelist down here. This is called Google Hangouts, which means it doesn't necessarily just have to be me. But all right, I'm going to get out of here for now, and glad you could stop in either live or if you're watching this later, glad you're watching. Make sure to share this around. I'm trying to spread this around. I want the circle of friends to get larger and larger and larger. Have a you know good conversation here, a fun conversation. It's casual. It's open-minded and skeptical though too. So I mean, it isn't. I don't want you know to mess around. I want to talk astronomy for sure. But you know, bring your questions, bring your comments. Go to the Discord server, post links there. I like to look at those. I'll talk about them during on the live stream. Yeah. All right. I'm going to get out of here for now. Thanks for joining. Take care. Have a great night. Have a great day. And I will see you again on the spin less than 23 hours from now. All right. Take care. Bye.